Hi everybody, so today we are here to conduct a very simple experiment in physics using spherical mirrors. So here I have a spherical mirror which is a concave mirror. Now how do I know that this is a concave mirror? It's very simple, it's curved inwards. So I know that this is a concave mirror because the reflecting side is curved inwards, right? But is there anything written on it? There is nothing written on it to identify what is the focal length. So today we are here to identify what is the focal length of this spherical mirror, which is a concave mirror. Okay, and you know, right, that this mirror has the ability to turn your world upside down. I hope you know about it. Why am I saying that? Now let us quickly see what are the apparatus that we are going to use. So I have a spherical mirror which is a concave mirror. Then I have a lens stand or a mirror stand. We can use lenses also, mirrors as well. We have a screen. I have a small support for this lens stand. I have a candle over here, a measuring tape and a matchbox, of course, to ignite the candle. So let's quickly start with the experiment. Okay, I have arranged the apparatus in a particular fashion. So the experiment is quite simple. The logic is the rays of the light from the candle will fall on the mirror and the mirror will create an image on the screen. So I just have to get the mirror in a proper position so that you get the image. If you see, there is an image which is formed on the screen. But if you observe carefully, the image is magnified as compared to the candle flame, right? See. So what we are going to do now, see, if I am arranging this apparatus in this fashion, I won't be able to identify what is the focal length. So what I am going to do over here is, I am going to place the screen over here such that the object is placed at C. And you already know what will happen if the object is placed at C. The image will also be formed at C. That means the image will be formed on the screen, right? So we can say at that position of the object that the image and the object is formed at the same distance, right? So let us do that. Now I have arranged the screen at the same distance from the mirror as the object. Okay, so if I get an image over here, I have to of course change the distance of the lens. I have to adjust it by a trial and error method. So if I get the image on the screen, the object position will be at C. So let us do that. See here. Now the size of the flame here and the size of the flame here are exactly equal. Of course, I have to change the angle with respect to the straight line from the object a little, with respect to the candle a little, so that the image is incident on the screen. So the rays are coming here and they are reflected on the screen and we are getting the image. Let us measure the distance between the mirror and the object. So over here, if you see, we are of course taking the distance from the mirror over here. So the distance is exactly 16 centimeters. Okay, till the screen, the distance is exactly 16 centimeters. So we have observed that the distance between the object and the mirror was 16 centimeter. As I said earlier, the object must be placed at C because we get the same size image on the screen if the object is at C. You also observed that the image obtained was inverted. That means it was real, right? All the inverted images are real. So if the value of C, that is center of curvature, so the distance between the mirror and the center of curvature is 16 centimeters, the focal length will be half of it, right? So the focal length for this concave mirror is 8 centimeters. I hope you have understood why the image was inverted and how to calculate the focal length of a mirror. Thank you so much for watching, people.